Hello, hello, hello. How is everybody on this Thursday evening? Hope everyone is doing well. Tonight's stream is going to be a little bit different from the rest. Usually it's just me talking and kind of presenting around a particular topic, but today's stream is just going to be the CodinGame Spring Challenge. And that has gone live. That should be 2 hours now that has just started, and it's a 10-day challenge. So it's really a challenge that a lot of people are going to be really giving it a bash to try to get to top positions. And let's go check it out.
Hello everyone, I'm Julian Paul from CodinGame. I'm here Spring Challenge 2020. So let's take a look at it. As you can see, it's a type of Pac-Man game. Each player controls one Pac-Man, and the aim of the game is to eat more pellets than your opponent. In this game, I'm the red Pac-Man, and my score is up here on the left, and the score of the blue Pac-Man is up there on the right. My algorithm today is just move to this coordinate, which is what my Pac-Man has done. This is actually just the beginning of the competition. Once I've created an AI, I can click on the submit button to send it to fight other players in the arena. And if it beats more people than the boss does, I'm promoted to the next league where more rules are unlocked. This is level 2, where both players control several Pac-Man. So I'm going to have to adapt my code to this new rule and try to win more matches than this new boss will. And if I manage that, I'll be promoted to the third league, where I will unlock the full version of the game, and I'll let you guys discover for yourselves what that will look like. So how does one actually play? Well, first you're going to want to read the statement, which is right here underneath the viewer, because it contains all of the rules and details of the game. But what it boils down to is writing some code here to read the contextual data of each turn from the standard input, computing the best move for your Pac-Man, and then outputting that onto the standard output. Some default code is available to help you get started. So what you're going to want to do is implement the most basic strategy you can think of. For instance, you could select the pellet which is the closest to your Pac-Man and move towards it. Once you have this simple AI which works and scores a few points, you can build on it incrementally and make it better and better. If you're looking for ideas, you can always observe what the boss does, or choose a player from the player selector down here and see what they do in the same situation. Pressing the play button will run your code locally. That's how you're going to test your algorithm. Once you're satisfied that it works, and press the submit button, your AI will be fighting other people's AIs, including the boss, in the arena. Inside the last battles panel, you can see all of the battles that were fought, and you can even send them back into the IDE in order to test your AI in the exact same situation. This will help you identify what is wrong with your AI and improve it. So that's it. I hope you have fun and good luck. Bye.
All right, so that is essentially the intro that I received a few hours ago. And now, as you can see, this is completely fresh. I've not had a look at this. I've not had a look at any of the code. Let's give it a bash. As usual, a few disclaimers. I'm not any kind of AI expert. The vast majority of my work that I do in code is actually web and UI based. So this is really not my area of specialty. Nonetheless, I'm going to give it a bash. So enjoy the ride, and let's see what we can do. I'm just gonna run this and let's see what it does. Alright, so much like the video said, it's largely just pointing at a particular spot and trying its best, or aiming for that particular spot, and off it goes. So yes, I am obviously not going to win. So let's go through the details of this challenge. Naturally, eat more pellets than your opponent. Pretty plain and simple. The game is played on a grid given to you at the start of each run. The grid is made up of walls and floors. In this first league, each player controls a single Pac-Man that can move along the grid. The map. The grid is generated randomly and can vary in width and height. Each cell of the map is either a wall, represented by a pound character, a floor, represented by a space character. Maps are always symmetrical across the central vertical axis. Most grids will have floor tiles on the end and right edges. Packs can wrap around the map and appear on the other side by moving through these tiles. When the game begins, the map is filled with pellets and the occasional super pellet. Landing on a pellet with your pack scores you 1 point. Super pellets are worth 10 points. The pellet is then removed. So, Pac-Man. Each player controls 1 pack, but in the next leagues you will have to control up to 5. On each turn you have vision on all of the pellets and packs in the grid. This will change in a future league. At each turn you are given information regarding the visible packs and pellets. For each pack you are given its identifier, whether it's yours or not, and its coordinates. For each pellet you are given its coordinates and value. Packs can receive the following command: a move. Give the pack a target position. The pack will find the shortest route to that position and move the first step of the way. The pack will not take into account the presence of pellets or other packs when choosing a route. Okay. See the game protocol section for more information and sending commands to your packs. Crossing paths or landing on the same cell as another pack will cause a collision to occur. In that case, the movements of the colliding packs are cancelled. Game end. The game stops when there are not enough pellets in the game to change the outcome of the game. The game stops automatically after 200 turns. The winner is the player with the highest score, regardless of the amount of surviving packs. Defeat conditions. The program does not provide a command in allotted time, or one of the commands is invalid. Some tips. Hover over the grid to see the coordinates of the cell under your mouse. Hover over packs to see information about them. Append text after any command for a pack and the text will appear above that pack. Press the gear icon on the viewer to access extra display options. Use the keyboard to control the action, space to play/pause, arrows to step 1 frame at a time. Game input. Line 1, 2 integers, width and height size of the map. Next, height in lines. String of width characters, each representing 1 cell of this row. Is that dots? No. 2 apostrophes is a floor. And hash is a wall. Input for 1 game turn. So we have the initial input, which I'm assuming we can just store away and continue to use. First line, 2 space separated integers. your current score, score of your opponent. Second line, 1 integer, with the amount of packs visible to you. Right. Next, visible pack count. So next number of lines for each number of packs that you can see. 6 integers, the ID, the pack's owner, which is a 1 or a 0, X and Y position, the type ID is not used in this league, turns left, speed turns left, and ability cooldown, both unused in this league. 1 integer for the amount of pellets visible to you. Next, lines, 3 integers. X and Y, the pellet's position, value, the pellet's score value. Alright, so constraints. Response time per turn is less than 50 milliseconds. Response time for the first turn is less than 1000 milliseconds. So that's fairly standard. Alright. So based on this, we've essentially got to try to come up with an algorithm that we can use to essentially avoid our opponent while maximizing the number of pellets we can receive. So a standard, I assume a standard aim would be to try to grab as many of the super pellets as possible. And it may be as simple as aiming for a super pellet. Once we've reached that super pellet, we aim for the next one. And this would be a very simple algorithm to try to solve the problem and try to beat our opponents. How's it? Well, just the intro video and just some of the rules in terms of how this works. But basically, today's stream, we're going to give CodinGame's Spring Challenge 2020 a bash. Probably take around an hour or so and see how far we can get. And if all works well, perhaps we can move up at least one league. I think for the... Oh no. Yeah. Alrighty. So JavaScript is my language of choice here. But if you scroll down, you can see there's a proper range of languages from C++, C#, Python, F#, Kotlin, PHP, Scala, TypeScript, and any number of others. So this is incredibly easy to get into, even if you've never experienced one of these competitions before. And the fantastic thing is, even once the competition is complete, after those 10 days have passed, it becomes available on the site for you to go and attempt at your own pace. So no matter when you're seeing this video, you can give it a try and see how far you get. All right, so what we have here, in the beginning, in the first turn, we will have the breakdown of this map, which, as was mentioned, is randomly generated for each run. And from then on, you will essentially have your game loop where you will receive information for that turn and you can make your move accordingly. So simple strategy that we're gonna give a try is essentially to aim for the super pellets, and that's going to be our simple strategy. Right, is there a way? There must be a way that we can identify the super pellets. Width and height for the floor. Packs of unless I'm missing something. Doesn't tell me how to identify the pellets and yeah. Oh, alright, so that's going to be interesting. Yeah, so we just know it's a floor or a wall, but we don't actually know. Ah, no, you do know. Amount of pellets visible to you. Ah, there we go. Okay. Oh no, no, no. So let's try this. We want to essentially identify the 4 pellets, or any pellets, or any super pellets, and then plot across for the closest one. Would be the simplest strategy. Alright, so then super pellets equals, it'll be an array. If value greater than 1, super pellets dot push. And okay, so from there we're going to get our collection of super pellets. The next step is to I think pick one. I mean, there's many ways we can optimize this. Okay, so move pack ID. And then pack ID XY. So we just need super pellets. Pick the lowest one as X. Does that work? Let's check it out. Right. Let's see if that works. Or that just bombs out. Wonder if it keeps rearranging the order of the super pellets. There's my messages. Right, okay. I had a suspicion that was going to occur. What if I can rearrange this? Alright, so I had a suspicion that eventually we're going to run out of super pellets. And when that occurs, we are not going to have any moves left. So then we just go for pellets. Well, since these are only pellets, so I go for some pellets first. I go F length greater than 0, so there are super pellets around. Else we do the same thing, but we just pick the first pellet that's available and we go for that. Alright, let's give it a bash. Howdy folks, so those of you who are just joining us, we're trying some coding in today's stream. This is the Coding Games Spring Challenge 2020 to celebrate, I believe, 40 years of Pac-Man. It's an AI bot challenge that I'm giving it a try, and let's see, perhaps if we can manage to get into the next league by the end of today's stream. Nonetheless, this is still Code to Korea, so as usual, if you have any questions, if you have anything that you'd like me to talk about, please feel free to drop the messages in chat. In this particular case, I am the red bot. Fantastic. And I managed to win. I was actually looking to see if there's actually just a way to speed it up a bit. Speed. Let's go 5 times speed. Try that. And the strategy here is very simple. Essentially, we got the super pellets, which are worth, I believe, 10 points each. And then we have the normal pellets, which are worth 1 point each. We get told each turn where the pellets are and what the values are. And what we're essentially doing is we're just creating a list of super pellets, and then we're creating, otherwise, we're adding the normal pellets to its own list. And then each turn, we've got to tell it what move should you do. I assume so. Yes. The boss of each level, as it is, or the AIs, are their names clearly say so. So that's what we're doing. We're trying to write a very simple bot to get more points than the opponent. That's essentially what it's all about. All right, so we've managed to beat the opponent that's been assigned to us. So now we can submit our code, and what will essentially happen is it will go up against a bunch of other players and bots in our own league, and I believe if we manage to defeat them, or defeat enough of them, we will move forward. Right, so there's 10 battles here which are about to occur. And I've won some and I've lost some. So I've placed number 175 in this league. No, that's not me. Oh, 208. All right. So, not fantastic. Trying to figure out if I've gone through to the next league. So I won 7 and lost 3. It is a bit of an odd system that I haven't quite figured out. Let's have a look at those that I lost. So alright. So there's some simple optimizations here that can be made. Time constraints permitting. There are 200 turns, so you have to do what you can within that time, where each block that you move is 1 turn. Additionally, yeah, so there's definitely some optimizations that I can make here. And that optimization is largely so I earn some experience. Can I resubmit the same and get more experience? I wonder. Yes, so what I can do that may very well assist is, instead of just randomly picking, see, this is much more evened out. Oof, okay. That's actually made things a lot worse. I've lost about 150 places. And that's the other thing about these challenges, is that because it's the beginning league, these move very quickly. And additionally to that, a lot of people share their code, and they're not particularly picky about using other people's code at this level. So you have people who essentially drop a piece of code that's going to possibly get them through to the highest levels, and off they go. So what we can try to do is, we can try to find what is the closest pellet or super pellet to us. So we have here, so let's go with our position. So we want to aim for the closest pellets to where we are. Ultimately, you would have an almost half AI, half statistical algorithm that will aim to get the most pellets and compensate by trying to avoid your opponent as well. Keenan, probably the Blinky guy scored higher because his code is not static. Like how I'm making changes to my code now, his code may well have improved, because I would have gotten a version of his code when I started, and by the time I submitted, he may have already moved forward to a better, improved version of his code. So, yeah. So what we're going to try to aim now to do is to try to find the closest either pellet or super pellet to ourselves. Now the question here is going to become, if you see here, there are some time constraints. So your response time per turn needs to be less than 50 milliseconds. So from that perspective, if we're going to traverse the tree and try to find a pellet or a super pellet closest to us, that's going to be interesting, because in the beginning there are a few super pellets, and so that list of super pellets is small, and so we should be able to efficiently go through that list and find who is the closest super pellet to us. And then even along those lines, the algorithm we can use can be twofold. One is, we can just use a direct line algorithm, and we say, right, okay, I'm at this XY position, I'm looking for the least distance in a straight line, even though there's no diagonally straight lines in this game, a straight line minimum distance algorithm, and hope that the route that we take is fairly close to what we're aiming for. And the second scenario is we actually use some sort of, for example, something like a pathfinding algorithm. And a number of them, probably A star is one of the most well-known ones if you look into it. And that essentially will say, okay, I'm in this position. This is the nature of the grid. And each, and it's weight based. So each block will have a positive or a negative weight in this grid, and it tries to traverse different routes and to try to figure out how to get to where you want to get to, based on a number of different factors. So that you can write the code for. You can probably find a very simple and compact JavaScript version of that online. And you can kind of just drop it in there and say, here's my grid, here's my current position, here's where I'm aiming for. Find me the next move in that route. So the tricky part with that is that you're going to calculate all of these routes when really you're just looking for the next move. So some guys make this work by essentially doing things like using extremely efficient languages like C or C++, where you can just do a lot more in the amount of time than you can with many other languages, simply because it is so efficient. Other ways is that guys kind of restrict your board set. So they say, okay, I'm in this position. I need to calculate a route, but I just need to take a slice of the grid. I don't need to take the whole grid. I need to kind of take a slice of the grid and say, okay, let's go 5 blocks or 10 blocks in every direction and use that as my data set. And that kind of restricts and could bring the number of amount of processing you need to do into a reasonable amount of processing power and time. But for now, we're not going to look at anything that complicated. We're essentially going to look at shortest distance calculation. I'm just trying to remember what it is. So, who is your friend? Shortest distance between 2 points. All right, let's see. I believe it's something like x. Finds algorithm. Alrighty. Right, so it's, yeah, it's suspected it's something like that. It's a square root of x2 minus x1 squared plus y2 minus y1 squared. So let's give that a quick go. So I wonder if we can use functions. SD equals, let's see, x1 y1 plus 2 y2. I wonder if it'll know what to do with this. Return math dot, we have math. Alright, let's pull up my JavaScript library. JavaScript reference on W3 skills, math dot square root. Math dot square root. Then we want to also square. And that will be power. And that will be power. X2 minus X1. We're adding. So it shouldn't, I'm hoping that negative numbers should not make any difference on the count of the fact that we're squaring these numbers. Shortest are equals, let's make it something large, like 1,000. Then we want to say let's do for each pellet distance equals SD. Now we've got, let's say pellet.x, and then we got position x, no, position.x, position.y, p dot pellet.y, position.x, position.y. And then if that distance is shorter than the shortest distance, then sh equals that. We also want to do a pick, var pick equals that, because we want the shortest distance, but when we pick the shortest distance we also want to know which position we've picked, because if we don't, and at the end of the day we got it tallied where to go, and if we haven't kept a reference to what the shortest distance's position was, then we're going to lose out. X and Y is bigger than X. And then we can move let's try this. Let's see if this will even run. Nope. Canary property Y, line 60. Ah. Try that. Ah, undefined. It's going to be a bad move. X, Y. Right, let's see. There must be a way for us to output our code. log. See what that does. X1, Y1, X2, Y2. Let's have a look, see if they give us some information on how to output. Gear icon. Minimap. Size, theme, mode. Okay. Not quite what we're looking for. Let's make sure that everything is one five 112, and that's returning. Right. Let's go. So we gotta break this down. Difference 1 equals x2 minus x1. Cool. Distance difference 2 equals y2 minus y1. Then var power 1 equals dot power of difference 1. Var power 2 equals method power of difference 2. And then var square root equals method square root power 1 plus power 2. And then we want to solve that log. All of these, distance 1, distance 2, power 1, power 2, and square root. Aim being, we want to try to figure out where is this going off the rails. 17.5, so we're getting our differences. Yeah. Power to what is the question. There we go. Hey, all right, we're making some progress, so we can take you out. Let's see if you run now. No. Three, 7, 29, 11. Sending 3, 7, 29, 11, and it's getting back not a number. Let's see. Let's try out a few things. Let's solve that out. Does that exist? That's all about is not. Time to stop faffing around. CodinGame JS debug output. Let's see if it tells me. Well, not there at least. That's not JavaScript. And that's also not JavaScript. Alright. Try. Info. For those who've joined in, I know for some of you all this is not as fascinating, as interesting as some of my streams normally are. Alright, so that seems to put it in, but like I've mentioned before, you're welcome to ask questions. If there's something you would like me to chat about. Sometimes I can be blind as a bat. Oh! Okay. I think that worked. Okay. So now this gets much more interesting. In this next league, you're not controlling one, but you're controlling 5, I believe. A team. Up to 5 each. You still have full vision of the grid. So I suspect we follow the, I would say we follow the same logic. The only difference being that we're doing this for each separate for each separate pack. We may have to just invert the logic a little bit on account of we want to be able to assign specific packs to specific tasks. So from the perspective of, if we have a super pellet, or let's say we have 3 super pellets, we want to assign 3 packs to hunt down the super pellets, and the remaining packs to simply go after the pellets closest to them. So, yeah. That sounds to me like a decent strategy. How are we doing for time? 5 to 9. I reckon. Let's give it a bash. And hopefully that will be good enough to get us into the next league. So, in the way that we've taken this logic out, and from what I can tell, this does do the trick. Well, mostly. That was our mistake there. That's good enough to reduce to 1 line. We may want to break it out an additional level and find the move for each pack. So for here, alright, so we're going to want here to replace position with packs, which is going to be an array. And in there, we want to say if it's mine. We actually want to keep that out. If it's mine, each one has an ID, I believe, pack ID. That P equals, I don't know. So we're gonna be keeping track of that, of each of our packs, so that when we assign them to move to a particular place, we can keep track of those commands outside of the game loop. So this while loop that we see here, this is the game loop. So each turn occurs as each command in here. And each time this runs, we're getting updated information in terms of our opponent's information, the current packs that are on the board, both ours and the opponents, as well as the current state of the board, how many pellets are left, and so on and so on. So when we assign a task to a pack to say go to that pellet, we want that to remain across each turn, as turn by turn each pack is aiming for a particular position. If it's and then we got to manage essentially 2 things from that perspective. One is we got to check, okay, is our pack moving? Although that's not so much a case, because the path thing happens automatically. We just tell it where we want it to go and it makes its way there. And the other thing we got to take into consideration is, does its target still exist? If a pack's aiming for a super pellet and the opponent munches up that super pellet, then we don't want to go after that position any longer, because it's gone. So from that perspective, we want to go look elsewhere. Alright, so that's why we want to keep track of certain things that are about our packs outside of this loop. So firstly, we're gonna have a pack, and we're gonna, as we enter into the game loop, the first thing we want to check is, can we find our pack? So that's where we're going to do p dot, I believe it's pack ID equal to current pack that we're looking at. Now, there are two scenarios here. Either the pack exists or it does not. And in the first round, it wouldn't exist because this is an empty array. So if that pack exists, then we're going to essentially update its position. Alright, so we're going to say p dot x equals x y. So for now, that's really all we're interested in. Otherwise, it does not exist, in which case we want to add it in. And currently, we're only interested in 3 things. Y and its ID. Okay, so this will allow us to get our group of packs and store them away. Once we have that, we essentially want to say to find the target. So this logic we want to essentially pull out into its own function. Right, firstly we want a collection of targets that we want to aim for, and we want its position. And then we can pull this logic out into there. Alright, so super pellets is our collection, and our position is our position. Yeah, that's actually what we're looking for. Now, yes, this is not going to work 100% initially. So to start it off simply, we can essentially say just find the nearest super pellet to the current pack and go for it. It's not going to be particularly efficient, but we can try that and see. Over here, for each pack we need to output an action. Right, so we want to say we also want to keep track of how many moves we've assigned to We've currently assigned that. So if they are super pellets, and the super pellets are less than what we've assigned. So each time we assign someone to go after a super pellet, we're going to roughly mark that as used. Okay, we're going to say target equals find target. Alright, then we're going to pass him super pellets. And then we're going to pass him actually P should just work like that. The pack. And then over here we're going to add in P dot pack ID, and we're going to add in a space, and we're going to go target.x, target.y is this, right? Then we're returning so let's put in some debugs. So this will take out for now. And this code will essentially be the same, yeah, except instead of super pellets, we're just sending through pellets. And then each time we assign here, we gotta increase M. This may be n equals to. Let's see how it goes. Right. Super pellet. Target. Let's go P dot pack ID. Target dot X. Target dot Y. Otherwise, it's a pellet. Right. Give that a bash. Hope there's no coding errors. Pinky has so many pellets that they can't be defeated. Ah. Okay. Okay. Who is outputting here? There's no P or SP. Just trying to figure out. Ah. Okay, so in another perspective, let's have a look, see what is actually going on. Nope. My guys are completely freaking out. The question becomes, why? Try that again. Ah, see, some of them are not receiving commands. Just no super packs. Oh, it's my super packs code. 14 super pellets. Yeah. So, as long as there's an M to assign. Let's see what that looks like. Interesting. Alright. Let's see if we can track down where the logic is going off. So for starters, I don't seem to ever move on to pellets. No, I do eventually. I'm largely telling everyone to go to the same pellets. Huh. I suspect I am misunderstanding how my output needs to be done. Input, input, output. Ah, that's changed now. You still need to, for each command. Alright. Right. So then command plus equals and then a space. Alright, let's do this differently. Commands equals array command dot push command. And then essentially commands dot churn. And there is a JavaScript arrays. It is join. I can give it separator. That's the join. And in this case, it's a space, pipe, space. Based on that, we can right. Let's try that out. Ish. That's interesting. All right. So we need a bit of. Given each level is randomly generated, there's a good chance I could avoid this issue just by generating a new level. So what we want to do here is we want to find the target. See, none of them were aiming for any of the spots around them. So let's have a look, see what happens here. Once they group together, okay. As long as I can avoid it, I can do decently. That's an annoying problem to have, because they're going to group together, and when they group together, they're going to go after the same target. No, they're not. If you look at these two guys here, so the front guy goes for the nearest one. But only after he's gobbled it does the next guy go after the next one. Let's see if I can. But it's going to lead to the behavior. Where they're going to come together. But hey, let's submit this and see how well we do. Sure, Pinky is up to 37. Okay, I've won quite a few. Won almost all. Fantastic. So, I'm curious about this one. Why did we lose this? Okay, not quite sure whether that's going to replace my code or not. I had two guys and they essentially got stuck. Alright. So let's try to fix this. As the leagues kind of change, this code and my standing will improve. Both from the perspective of some other guys will go way up into the next league, and so my position will improve. But also others will enter the league and yeah. How would we go about fixing this issue? I wonder. Yeah, it was a pretty good round. Let's do a bit of cleanup. Okay, so how would we solve that problem? Chat, any ideas? So firstly, we can detect if we have not moved in a round. Because each round we should be changing position. Yes. Yes, the aim is to eat more pellets. The problem is to stop ourselves from getting stuck. So the one thing that we could do is if we detect that we have not moved from the previous turn, previous round, we retarget a random position. I think that would be a fairly good way of doing it. Because the idea getting stuck that we're going to keep trying to go after the same thing, and we want to avoid going after the same thing if it means we're not going anyway. So we are saving. We're saving away our current position. Right, so we could do a check. If P exists, right, then we got two scenarios. Either our current position is the same, right, because at this point it's still got the previous x value. If it's the same x value and it's the same y value, have it moved. Otherwise, we're good. Actually, we don't need that because we're going to always be updating this to our current position. P dot random move equals true. Now let's see that. Because we also want to be able to set it when we no longer need to do it. Now we'll have to just monitor this, but there's a risk that we could say move randomly. Okay, we move one position, then no, go back to our previous closest target, and we're gonna essentially go from constantly clashing to going away and clash and away and a clash and away and clash as we keep coming back to trying to go to that particular position. We will try it out and see. Here now. Right, so we're passing in P. So I guess we can implement this as part of our find target. If position dot, what did I call it? Random move. Right, if it says random move, we have our collection. Let's see, math.random, I believe it is. Let's do this. Return collection, one item from the collection. Random multiplied by collection dot length -1, and we wanna floor. The floor is, I believe, rounded down. Let's see. Floor. Yes, round the number downward to its nearest integer. You want to pick a random method. Random returns a value between 0 and 1, which we then multiply out by the length of the array to get a random value within that range. To -1, because we can't select the length element of the array because it's 0 numbered. That's why we floor it down instead of round, which could risk of going into that value, which we can't select from the array, and then we'll selecting that element from the array and then returning that. Okay, and then just going to put in there random, so we know that's occurring. Sorry, with my IDE, I'm very used to hitting Control S to no. Is this guy, I don't know what the strategy is. Huh. But the problem here is there's only one super pack left, and all of my guys are fighting for it, along with 2 out of the 3 of his guys. Yeah, they do. Oh boy. Okay, so this year is a problem with this. Why? Because super pellets there are super pellets left, because in this case we can see there is 1 left. Let's just super pellets. M. Let's add that. Oh, no. Wrong spot. There. Alright, let's run that in. See what we get. Alright, so in this case now I've moved on. Okay, let's rerun that again. Okay. So we're going for super pellets. There are 4, then 3. Okay, so I've got 4 guys, but 0 and 2 are trying to go for the same super pellet. Yeah, we're down to 3 super pellets. Why has an M moved up? I am a monkey making silly code mistakes. So M is not moving up because every single time I'm looking at a pellet, I'm resetting M to 0. Okay, that looks fantastically good. Oh, it seems I'm being promoted. Cool. Never noticed this up here before. But okay, let's see. Now M's moving. I've got 4 guys. I've got 4 super pellets. Good stuff, good stuff, good stuff. Sure. Took you guys a while to get to the super pellets. Actually, okay, let's see. You can now give a speed boost to your packs. You can now switch their type to attack your opponent's packs. You can only see packs and pellets that are in the line of sight of your packs. Ah. Alright. And on that note, I believe we'll leave it at that. Although, out of curiosity, I'd like to just, I'm assuming the output is still the same. So I wonder, move. So there's a move. Pack will be able to move 2 steps during, move by 2 steps. Switches to a different pack type. So I'm curious to just run. You see now in this case we've got a default AI. So you're not actually playing against somebody else. But I'm curious to just run my code and see how well it does. Try that again. Oh, he probably just got there way faster because he used the speed boosts. I'm curious how that works. Alright. Oh, but you can't even see where they are either. I'm betting my guys just didn't know what to do. Because So there's two problems here. One is that I probably, I can see them. Can see that there's 4. I'm going after those. It's down to 2. Go 2. Down to 1. Why have I not moved on to packs? Okay, that could be just greater than equals to versus the equals to. See, now I'm moving down to packs. I'm guessing that format has changed, which is why I'm getting undefined data over here. And then I can look further into that. Yeah, so this is how the tournament works. As you go higher up in levels, you get to more and more functionality. And the idea obviously being to build more and more complexity into your bots. But not only that, you start entering what's called the metagame. So what will happen is you'll have a bunch of people using the same ideas and the same strategies. And you start building a strategy specifically to beat their strategy. And then once that happens and your strategy starts becoming popular and other people start doing the same thing, then people will start to build strategies to beat your strategy, which you built to beat a different strategy. And so all of these strategies kind of shift around in popularity, and more of the code kind of becomes a very statistical type of type of thinking to really progress to the highest leagues, because you got to kind of decide, okay, statistically, what is my chances of success with every move? So you start building these models, like how I'm saying, like currently my largest factor to determine my chances of winning is going after the beat that's closest to where I currently am, and that's all the logic that I currently have built in, and that's incredibly simple. Now, as you start having things like the ability to attack, not just attack but be attacked, you got to start making much more complex decisions. Should I be attacking, or should I be going after points? Should I be doing other things? If the guy is moving towards me and he's not in attack mode, I should attack him. If he's moving towards me and he is in attack mode, I should run away. And you got to kind of look at how your opponents are behaving and respond accordingly. And you got to look at how you're currently positioned. You got to look at the present. What is the current situation? And you got to not just determine your current moves, but you got to also build some foresight into the logic. At the end of the day, it's not just about attacking your opponents or responding to his attacks. You got to also go after the points. It's not necessarily just a case of running away. It's a case of how can I efficiently run away so that I'm still getting points, even though I'm not getting attacked by I'm staying out of my opponent's reach, so to speak. So there's all sorts, and this is just like Bronze League. So I'm not sure what leagues there are currently. Let's have a look. Yeah, this is probably just full leaderboard. Let's have a look, see what we get here. Right, so I'm in Bronze League. Right, so currently it only goes, I don't know if this only goes up to Bronze League because I'm only up to Bronze League. So yes, so currently it will only go up to a certain league, but as the days go in the tournament, maybe 2 or 3 days in, they'll every 2 or 3 days they'll open a new league, and which with each new league you have an updated set of the rules, and based on that, you'll have okay, not where I was looking to go. Oh, I don't want to start. I'm already taking part. Okay. Anyway, yeah, you'll have new functionality that you'll need to try to build into your um, into your into your logic and into your engine, and you got to do all of this, so to speak, thinking within 50 milliseconds. So that's not easy, but it can be done. But ultimately, if you want to get to near the top of the leagues, you I don't know. Let's see. There's bronze, there's silver, gold, all the way up to legend, and that's no. I believe we. I'm not sure about silver. This tells me it's 11th of May. So in 4 days' time, they may open silver onwards. It's not exactly clear, but there we go. Top 10, few last battles. Alright, let's go have a look see at that more closely. Can I just adjust? We can adjust that to, let's say, 2 times speed. Stop it again. Alright, so we can see there's different modes that he's going in. He's using the speed. He's using the he lost 2, but he managed to take 1 at the end. But probably his focus was much more on getting the pellets than it was on battling the opponent. Was it health pass? I'm not sure. I don't think that's health pass. I think what that is. Oh, I think that's the recharge for the fast. So if a particular pack gets enough pellets, you can use the fast. Either that, it's kind of just accumulates. Yeah, he's getting pellets at an inconsistent rate, yet it looks like the fast is still able to kick in all at the same time. Yeah, most of these guys have been eaten. And so this is the kind of thing that I'm talking about in terms of how the metagame shifts. You know, guys will be greedy and not want to attack much. And based on that, they may do quite well and go up the rankings. But as they're being too greedy, they're not protecting themselves. And so the focus for others will start to shift to attacking more. And that will start to take out the guys who are not attacking or defending much, because they'll lose their packs. But then as time goes, they'll start to defend and attack more, and it'll become much more attack focused. But then it'll start swinging the other way, because guys will be attacking too much and not getting enough points. So then that it'll start swinging back the other way, where it's like, okay, yes, you managed to take out most of my packs, but I still got more points than you. It'll be that kind of thing. Yeah. All right. So I think let's call it there. It's been an interesting one, and especially if you're working, kind of in a group or in a team on these and trying to come up with ideas and solutions. You work as a team, you split up the sections of the algorithm. If there's 3 of you all, you have one person on target finding and write a function for that, one person on pack safety, for example, and have someone focus on that, and you have someone looking at kind of looking ahead, that kind of thing. It can be a really fun time. And then what you do as well on top of that is you kind of swap around and take turns with different parts of the code. All right, some questions. Is JavaScript running through Node? I don't actually know what they're using to run it on the back end. As you saw, essentially, all right, why not? We'll just go back. I'm assuming it saved my code. Yeah. So as you can see, yeah, this is basically one function that everything runs within. And so it just takes it and executes it, and each game loop is in a while loop. And so there's an engine that kind of says, okay, I'm going to run 1 round for the opponent and 1 round for you. And it kind of splices those actions in between. And that's the set of actions which determines the animation and the game that runs in here. But then you can see those outputs over here. What the actual backend is that runs the code, I don't actually know. What determines the 50 millisecond tick is essentially that backend server. So it will say, right, okay, I need to wait for the next command, and then it's got a timer. And then when the command comes through, it will say, right, okay, it took so long, and that's within the time, or it is not. If you did C++, could it run faster? Definitely. It definitely can run faster. So, from that perspective, more than likely, you'll find the guys who are at the highest levels will either be running in C or C++, maybe some Python, a lot of the languages just don't have that level of resource control, for lack of something faster, to be able to get the performance in. Having said that, you can get yourself probably in the top 20 with almost any language, because having more, so to speak, processing power does not necessarily make your algorithm and make your logic model better. If you're comfortable writing in JavaScript and you're really good at AI, and remember, for a lot of people, especially if you go and study AI-based courses, it's as much math as it is logic. What you would learn in one of these AI courses looks very different to what you would if you did a standard computer science course or degree. So, and the reason is because it's much more about the math. It's less about logic and binary logic, and much more mathematical models and much more statistical. So you're working in that realm, and the software and the code is kind of just helping to extrapolate that, and a language to think in those means. So if you can, if that side of your skill is very strong, it almost doesn't matter what language you're in, you're probably going to do incredibly well, because as simple as it is, you're essentially going to just outsmart your opponents. You're going to see what they're doing, and you're going to be able to understand it in a mathematical and statistical manner that will allow you to outsmart your opponents. And a lot of that side of it, when we look at it, we're looking at it very logically, and we're kind of trying to compare ones to ones and compare twos to twos. And we're doing many of those in the way software developers tend to think normally, and in most cases. But in the AI realm, it's about reduction. It's about taking all of this complexity and reducing it into something much simpler. And I mean simpler by output, not necessarily simpler by what is happening. And you want to try to represent as much as possible in a bunch of numbers. So you may have a complicated function, and the function is not about, in the way we write the code, you would have a complicated function. The output would be, what is my position that I should aim for a particular pack. On the AI side, you would have a function, and that function will return to you for each position on the board. What is your chance of success as a number? And you would, in the beginning, it would seem like it's overkill. But as time goes and you're including more and more complexity, and each round what your opponent is doing becomes more and more important, because it's not just about getting the points, it's about outsmarting your opponent. That kind of model starts to become more and more powerful, because you split that out and then you build in logic to cater and think and work in that manner. And then as you take a more pure AI attempt at solving it, even more and more of those become much more abstract checks rather than direct checks. You're not doing masses and masses of if-else statements over here to say, okay, is my opponent in my line of sight? And if that's the case, then I need to consider these sets of things. Otherwise, do I have a super pack? If I do, I need to consider these set of things. Otherwise, or else. And you're this kind of logic, you're going to end up in that place inevitably. Whereas the more statistical way is to say, okay, I am wanting a number for this pack. And maybe the number represents opportunity. And based on that, you can say, right, okay, if my opponent, and it's going to be, let's just say, in a scale between -1 to 1, where 1 is there's a lot of opportunity for points, and -1 is there's a lot of danger. And then you build it along the lines of saying, okay, is there a super pack within my sight? If there is, bang, +1. If there is there a because that's the maximum number of points you can aim for, is 1 super pack. Is there an opponent within my sight, an opponent pack, and is he in, so to speak, manhunter mode or pack hunter mode? If he is, -1, I am in danger. And then, based on that, you can very quickly get, okay, what should I consider? And then break your functions up accordingly. So then, if you've got a high points opportunity, then you call the get super pack function, get super pellet function, and you aim for that pellet. Otherwise, if you're in a lot of danger, then you got to run, okay, get duck and cover function or something along those lines. And now the question kind of becomes, between -1 and 1, how do I choose when to run these functions? And then it becomes a data game. So you kind of say, okay, I'm going to set it to say, okay, if let's say I'm going to break it up into 4 quarters, each one being half a point across the range of -1 to 1. Let's break that range up into 4 quarters. If I'm in the lowest quarter, I'm going to duck and cover. If I'm in the highest quarter, I'm going to go super pack mode. Otherwise, just go for points. Something like that. And you try that out, and you'll win some and you'll lose some. And because you're not going to be able to beat every opponent, because guys are going to keep trying to adapt. And then you break it down and say, okay, you know what? As the way currently is, not a lot of guys are going into manhunter mode. So I can probably be a bit more risky. And so then, instead of it being the top, the 1 in the middle and then the 2 quarters on each side, you can say, okay, let's split it into thirds. And then something like that. And you tweak those numbers and you adjust those numbers. But then you also look at the output. You collect that output and you say, okay, this is what's worked well for me. This is what's not worked well for me. And then you start taking other inputs. How much of an effect does the number of super pellets have on my output of my chances of winning the game? How many packs I had in this round? How does that determine my chances for success? And you start getting data and statistics out of that. So based on these things, your whole way of thinking becomes very different, and your whole way of coding becomes very different. And it's because you're thinking in a very artificial intelligence manner, a very mathematical and statistical manner, rather than looking at a very logical manner, which we as more standard software developers tend to do, to kind of say, okay, we want to compare whole numbers rather than looking at the fine-grained numbers and the value we can get out of that. So yeah, that's just kind of some idea on the different approaches and the different kind of the way your thinking has to shift as you get into the more complicated and the parts of this challenge. So along those lines, the difficulty with having this kind of code as well is that it becomes very brittle. So suddenly they say, okay, you have a kamikaze pack, and if you activate it, all opponent packs within a 4x4 range, they're toast. And so now, to try to integrate that behavior into an existing kind of decision-making structure like we have here, you basically got to start from scratch, because trying to insert that code into the logic it needs to go to, it's going to be a nightmare. You're not going to succeed. Each time you're trying to cater for one new set of capabilities, you're going to double or triple the amount of code you got, and very quickly it is going to go out of control. And the same difficulty along with that is it's also brittle in the sense of you can't respond to your opponents, not easily. As the metagame changes, and as the guys you're going up against are changing their behavior and changing their patterns, changing their models, you can't. Not easily, because you've got one logical path based on what is currently happening every single time. If the current state is the same, your output is going to be the same. And to try to change that is incredibly difficult. So, there's lots of these kinds of considerations that you need to have. And it's fascinating. Just looking at what the other guys are doing. As you can see, the entire time I've been doing this, the chat channel has been incredibly busy. As you can see, there's a Discord server as well. So if you go on to there, you can see, I'm sure there'll be many boards and there'll be many people participating, and you're gonna be able to really learn a lot just being part of the experience and just seeing what these individuals are doing in whichever format you can participate in, being it by yourself, being it with a group, being it with some co-workers, being it on a bunch of guys who you can just randomly find on their forums or on their Discord server. I have no doubt that there are individuals who are doing that, or they've probably got an area there where you can go and ask to join a team, be part of a team, recruit guys onto your team. So that could be a really interesting experience. So there's so much you can learn just by being part of the process, just by being part of just being part of that experience. Sure, you're welcome. All right, so I think let's call it over there. For those who come in and want to know more about the more abstract and more career side of development, there's probably not that much that you got out of today's session. But the interesting thing is that these come along at as these come along, take the opportunity. It's I believe a few of my discussions I've brought up CodinGame, all these kinds of experiences, and now you can kind of see for yourself what it's about, and at every level that you can go to, whatever time you can spend, you can learn something. The code is not difficult, the logic is not difficult. So if you're wanting to say, you know what, I'm coming from a UI perspective and I know JavaScript and I know TypeScript, but I want to give Java a bash, I want to give Rust a go. Why not? Go. As you're trying, you probably can't even read the code, but go on Google and try to figure out what's going on and take it from that perspective. Obviously, your aim is to have something interesting to do while trying to learn a language. It's not about going and saying, right, I've never used D before, but I'm going to try to be the top of the league. No, you're not going to get there. To get high in the league, you need a good understanding of a language. But that's not what it's all about. If you're trying to learn something new, one of the hardest things to learn when you want to learn something new is to have something to do, have something to aim for. Many of us developers are not sitting and watching videos and absorbing all of that. We want to write the code, we want to see it in action, we want to see the logic and how to solve a particular logical problem with that code. That's what we want to do. So this is one of those opportunities, and there are many of them. As we saw, this is thing. Puzzles. There are many puzzles. Don't panic. There's no spoon. And all of these have fascinating AIs. Most of them are UIs. They look interesting, they feel interesting, and it's something that you can use to aim for as you're progressing, as you're wanting to learn something new. It's an environment in which you can do that and keep yourself motivated. You have something to aim for while you're learning. Okay, so I think let's call it there. I think for the maybe for the time now. Thanks everyone for coming along. We were supposed to have a speaker today. Unfortunately, at an hour before the live session, he messaged to say he couldn't make it. He didn't have any power at home, so he didn't have any internet. So that was unfortunate. But nonetheless, he has been incredibly committed and incredibly excited. So I have no doubt, perhaps next week, perhaps the week after, he'll pop in and say hi. Yeah. So thank you, everyone. Have a fantastic evening and a fantastic rest of the week. Tomorrow is Friday. Those on lockdown, I'm not 100% sure how much of a difference that makes. But be well, be safe, be healthy, and pop it next time, as usual, Tuesdays and Thursdays at 8 p.m. UTC +2 is when we run the live streams. We have a Discord server. Scroll down, details are there. I upload these videos to YouTube. Again, scroll down, the link is there. So go and have a look if this is your first time here. And yeah, thanks everyone, and let's go from good code to a great career together. Cheerio.